Assalamualaikum and good day everyone. In my previous video, I already explained to you the first properties of Laplace transform, which is linearity properties. So let's us recall on that first before we proceed to the second properties, which is first shift properties. So when will you apply linearity properties? When you have more than one function. So let's say you were asked to find Laplace of 2t plus 3 exponent negative 3t. So you have to split this function and factorize the constant. So you will have 2 Laplace of t plus 3 Laplace of exponent negative 3t. Okay, so this is how linearity works. So as you can see here, for linearity properties, we are dealing with plus and minus sign, isn't it? So for the second properties, which is first shift properties, we use these properties when you have a multiplication of two functions, okay, a product of two functions, and the one of that function must be an exponential function. Okay, so basically before this you have Laplace of ft is equals to fx. So this is for a single function, isn't it? So now if you have a product of two functions and one of the function must be an exponential function, so the Laplace of this function is equals to fs minus a. Okay, so this is the first shift property. So when you are going to use these properties, when you have a product of two functions and one of the function is an exponential function. For example, if you have your ft is equals to t exponent 2t, or your ft is equals to exponent negative 3t sine hyperbolic 2t, okay? Or if you have to find the Laplace of 1 minus exponent 2t t. So what you need to do first, when you expand this one, you will have t minus t exponent 2t. So you can directly find the Laplace of t by using table of Laplace transform. But for this function t exponent 2t, you have to apply first shift. Why first shift? Because this is a product of two functions and one of the function is an exponential function. Okay, so that's why you use first shift properties. Okay, so let's try to solve a few examples regarding first shift properties. So the first one, let's say you have to find the Laplace of exponent negative 3t cos 2t. Okay, so this is your ft, a product of two functions where one of the function is an exponential function. Okay, so how to solve this one? So generally Laplace of exponent ATFT is equals to Fs minus A. So first step is find what is your Ft by comparing your function and the general one here. So obviously your Ft is equals to cos 2t. Why? Because this is an exponential function. So therefore this is your Ft. Okay. So you know that your Ft is equals to cos 2t. So the first step is find the Laplace of cos 2t. Okay. Before that, sorry. Before that, just define your A first, because you are using the A in the next step. Okay, so what is your A? So how are you going to define your A is based on your power of an exponential function. So you know that your A is equals to negative 3. Okay, so you know that your A is equals to negative 3. So the next step is find the Laplace of cos 2t. So you will have Laplace of cos 2t is equals to, so this one directly from the table of Laplace transform. So you will have s over s squared plus 4. But this is Laplace of cos 2t. What you need is Laplace of exponent negative 3t cos 2t. So what you need to do is substitute s with s minus a. Okay, so you have to change from s to s minus a. So what is your a? So you already define your a is equals to negative 3. So therefore you have to change s to be s plus 3. So by looking at your function here, when you have s, replace it by s plus 3. When you have s here, so you will have another s plus 3. So therefore, Laplace of exponent negative 3t cos 2t is equals to, so now this is s. So replace by s plus 3 over, so again this is s. So you will have s plus 3 the whole thing squared. Be careful here, because s you replace by s plus 3. So x plus 3 the whole thing squared, not s squared plus 3. Okay, that is wrong. This is the right way of doing it. Okay, s plus 3 the whole thing squared plus 4. So therefore this is your answer. This is your Fs. Okay, Fs is equals to Laplace of this one, which is equals to this one. Okay, so I repeat again. Okay, so when you want to solve this problem, first step is define your A. Where to get your A is from power of exponential function. So in this case, your A is equals to negative 3. The next step is by comparing the function that you have and also the general one here, define what is your Ft. Okay, so you know that your Ft is equals to cos 2t. Okay, so now get the Laplace of cos 2t first, which is s over s squared plus 4. If you still don't know how to get this one, you have to refer to my previous video. Okay, so next, this is Laplace of cos 2t, but what you need is Laplace of exponent negative 3t cos 2t. So therefore you should replace s with s minus a. So in the first step, you already have your a, where your a is equals to -3. So therefore, you will have your s minus a is equals to s plus 3. So therefore, your fs is equals to, when you have s here, so replace by s plus 3. This one is s squared, so you will have s plus 3 the whole thing squared plus 4. So this is your fs. Okay. So next, this is the first example. So try to do the second one. Let's say your ft is equals to t squared exponent 3t. Okay. So what is your a here? You know that your a is equals to 3. Okay, by looking at the power of exponential function, you know that your a is equals to 3. So the next step, you have to find the Laplace of ft. So by comparing the function that you have with the general one, which is eatft, so you know that your ft is equals to t squared. Okay, your ft is equals to t squared. So get the Laplace of t squared, which is equals to 2 factorial over s3. So this one is equals to 2 over s3. But this is Laplace of t squared. What you need is Laplace of t squared exponent 3t. So you have to replace s with s minus a. So you replace s by s minus 3. So therefore, you will have 2 over s minus 3, the whole thing cube. Okay, simple as that. Okay, so I hope you can understand this one. So let's proceed to a complex function. Okay, we'll see how to use first shift. If you have your ft is equals to 3 plus sine hyperbolic sec 2t exponent negative t. Okay, here you have two ways of doing it. The first is by expanding this expression first, isn't it? So you will have 3 exponent negative t plus exponent negative t sine hyperbolic sec 2t. That is the first way of doing it. The second way of doing it is by assuming the whole thing here as your ft. So do you really need to expand this one? Well, it depends to you. Okay, if you expand, okay, I show you both way of doing it. Okay, so you choose which one is much more easier to you. Okay, so by using the first solution, by assuming your fx, by expanding this one, you will have 3 exponent negative t plus exponent negative t sine hyperbolic sec 2t. So as you can see here, when you expand this one, you still need to do first shift properties. Why? Because here you have a product combination of two functions, and one of the function is an exponential function. Okay, but for this one, you can directly refer to the table of Laplace transform. Okay, or another way of doing it is just by choosing your ft is equals to the whole thing here. Okay, because generally we have EAT FT, isn't it? So by comparing this one with the function that you have, so you know that 3, your FT is equals to 3 plus sine hyperbolic sec to t. Okay, so just take the whole thing as your FT. So I'm doing this one first. Okay, like say I'm doing the first one first. Okay, so you need to get your Fs is equals to 3 Laplace of exponent negative t plus Laplace of exponent negative t sine hyperbolic sec to t. Okay, so this is the first solution by using the first solution. Okay, so this one is directly from the table. So you know that 3 Laplace of exponent negative t is equals to 3 over s plus 1. Okay, but for this one you have to follow the previous step. So define your a. Your a is equals to negative 1. Your ft is equals to sine h to sec to t. So get the Laplace of this one. So you will have, I label it as this is A and this is B. Okay, so this is your A solution. So this is your B solution. Okay, so your A is equals to negative 1. Your FT is equals to sine hyperbolic sec to t. So therefore, Laplace of sine hyperbolic sec to t is equals to, so your A is equals to sec 2 over s squared minus e squared, which is equals to 2. Okay, so this is your sine hyperbolic sec to t. But what you need is Laplace of exponent negative t sine hyperbolic sec to t. So you have to replace your s by s minus a. So in this case your a is equals to negative 1. So you will have s plus 1. Okay, so therefore your Laplace of exponent negative t sine hyperbolic sec 2t is equals to sec 2 over s plus 1 squared minus 2. So this is your B solution and this is your A solution. So by combining these two functions, therefore your Fs is equals to 3 over s plus 1 plus sec 2 over s plus 1 squared minus 2. So this is the first way of doing it by expanding the function first. Okay, so the second one, by just assuming the whole function here as your ft. Okay, the second one is by assuming the whole function here as your ft. So we are using the same step. First you need to define your a by referring to the power of exponential function. So you still have the same a, where your a is equals to negative 1. Okay, but as for now your ft is equals to 3 plus sine hyperbolic sec to t. So what you need to do first is to get the Laplace of this one. Okay, so therefore your Laplace of 3 plus sine hyperbolic sec 2t is equals to So here, as you can see here, you have an addition of two functions. So you need to apply linearity properties. So basically what you need to find is Laplace of 3 plus Laplace of sine hyperbolic sec 2t, okay, which is equals to 3 over s plus sec 2 over s squared minus 2, okay, because your a is equals to sec 2, so a squared is equals to 2. Why minus here? Because this is hyperbolic function. So but this is your ft, which is this one. But what actually you need is Laplace of exponent negative t 3 plus sine hyperbolic sec 2t, okay, which is equals to, so here what is your a? Your a is equals to negative 1, so you have to replace s by s minus a. Since your a is equals to negative 1, so you will have s plus 1, okay. So therefore the Laplace of this function is equals to, so 3 over, so this is s, so replace with s plus 1 plus sec 2 over, again you have s here, so replace by s plus 1 squared minus 2, okay. So as you can see here, you will have the same answer, okay. So which one is easier for you? So it's up to you. As for me, it is better for you to just assuming the whole thing here as your ft, okay. But if you don't want, then you want to just expand first, then it's up to you. Because when you expand this one, you still have to do the first shift, right? So there is no use of expanding the expression actually, okay, because you still need to apply that properties. Unless when you expand you don't have to apply the properties, then it might be okay, but it's up to you which one did you prefer, okay. So last example. Your ft is equals to, I have mentioned here, 1 over 3 example 4. Your ft is equals to 1 over 3 t cubed minus 2 exponent negative 6t e 2t, okay. So again here you have to apply first shift properties, because you have an exponential function and another function, okay. As you can see in this bracket here, you have two functions. So it's basically the same thing as the previous example. So it's up to you whether you want to explain first or just assuming the whole thing as your ft. So I'm going to show you by assuming this whole thing as your ft, okay. So the first step is define your a. So your a is equals to 2. So where did I get my a? Is from this one, okay. As you can see in this example, you have two exponential functions, this one and this one. So you might be thinking, what is my a? 2 or negative 6? Okay, before you make any mistake, you just refer back to the general form of first shift properties. What is that general form? Generally, if you have Laplace of exponent at f t is equals to f s minus a. Okay, so by comparing the general one with what you have, so clearly your exponent 2t, your a is equals to 2, not negative 60. Okay, because you are letting the whole function here as your ft. So that's why a is equals to 2, not negative 6. Okay, so my a is equals to 2. So what is my ft? So my ft is equals to 1 over 3 t cubed minus 2 exponent negative 60. So find the Laplace of this one. So Laplace of ft is equals to, so this one here you need to apply linearity properties. So here you have 1 over 3 a constant, so factorize constant, then you will have to find the Laplace of t cube. Minus, again here 2 is a constant, so factorize 2, then you need to find the Laplace of exponent negative 6t. Okay, so by referring to the table, so this is direct from the table of Laplace transform, then you will have 3 factorial over s4 minus 2 1 over s minus a, so you will have s plus 6 because your a is equals to negative 6. Okay, so simplify this one will give you 3 factorial is equals to 3. So therefore you will have, 3 factorial is equals to 6. So you will have here 1 over 3, 6 over s4 minus 2 over s plus 6. So simplify this one will give you 2. 2 over s4 minus 2 over s plus 6. But this is Laplace of this one. But what actually you need is Laplace of 1 over 3 t cubed minus 2 exponent negative 6t exponent 2t. So your a is equals to 2. So replace s with s minus a. So you will have to replace it by s minus 2. So therefore your fs is equals to 2 over, so here you have s, so replace by s minus 2. So you will have s minus 2 power 4 minus 2 over, again here you have s, so you will have s minus 2 plus 6. So you can simplify this one because you have minus 2 plus 6 here and you don't have power for s minus 2 here. Okay, so therefore you will have 2 over s minus 2 power 4 minus 2 over s plus 4. Okay, so that is the answer. So I already explained to you 4 examples on how to use first shift properties. So take a look back. If you still don't understand, you can just repeat this video again and again, and if you are able to understand, so please try to do the exercise in your notes. Okay, so I shall see you in my next video with the last properties of Laplace transform, which is multiplying by Tn function. Stay tuned guys. Bye. Assalamualaikum.